Your subject matter expert for this course is Edwin Odeh. He has a wealth of knowledge and experience and is passionate about sharing it with you. Edwin graduated with a BSc in Computer Science from Dorset College in Dublin, after which he advanced his knowledge in cyber and digital security at IBAT College. Edwin is very enthusiastic about what he does. It has kept him motivated throughout his career. Having worked in the area of physical security and system administration in one of the best tech companies in the world, his specialty includes policy and architectural design, data loss prevention implementation, identity and access management, incident response, forensic analysis, and penetration testing. Just to remind you, my name is Nina Smith, and I am the presenter of this course. Hello and a warm welcome from Shaw Academy. Your journey to becoming a cybersecurity certified user begins here. Today's lesson is divided into 4 sections. By the end of this lesson, you should be able to discuss the considerations for setting up a computer network, identify hardware requirements to set up a network, evaluate different network types, and describe how to set up a small network. Before we dive into this lesson, you surely already know and have experienced that networking in a business scope knows no bounds. For example, thanks to networking, someone in another geographical location will be able to do business with you without having to walk into your office. Let's start with what you need to set up a small network. Introducing networking into a business in today's fast-paced, technology-driven environment gives it an edge to grow and connect with new customers. However, there are some important considerations to keep in mind when choosing the type of network to apply. And this is primarily based on the number of employees or users the network will need to service. The bottom line is that every business needs to aim for proficiency in its general operations. In other words, to run the very best operation you possibly can. A computer network would be one of the ways to achieve this. But operational proficiency can only be achieved by a clear understanding of the essential factors affecting this key business decision. What are some of those essential factors? Scalability is also a vital factor to take into consideration. When setting up a business, there's always extra room for growth and expansion. A typical example would be a hotel, starting off with 9 staff members, 9 rooms, and 9 guest rooms, using a wired connection for the hotel. Now, fast forward 5 years, the hotel has built 10 extra rooms along with a restaurant and a bar, and the staff is now close to 100. The hotel may need to change or update its network to deal with the increased capacity and demands. Maintenance. Hardware often comes with a life expectancy of 3 to 5 years, so you would need some form of maintenance structure in place for the continued efficiency of the system. And lastly, the business would need to consider security. The network is a business asset, and the hardware on their premises and software would ideally be managed by a cloud service. And in terms of minimizing problems and threats to the system. There are obvious benefits to introducing computer networking into a small business. These would include increased productivity and efficiency, best practices, so the business will be able to improve its communication and online conversations with customers through email marketing, social media, hashtags, conversations, and blog posts. Shared resources. No more emailing, copying to USB drives, or printing thousands of copies. Centralized administration, storage, and backup. Cost saving. Flexibility, so with wireless computer networking, employees can work remotely. And lastly, improved security, which is what this course is all about. The network infrastructure for small businesses is usually one of 3 structures: a wired network, a wireless network, or a hybrid network. Now, each network structure has specific equipment requirements. It will require things like adapters, switches, Ethernet cables, routers, wireless access points, and firewalls. All the terms we covered in Lesson 1. Let's look at the various network infrastructure options in a bit more detail. If a business has a wired network infrastructure, it would need an Ethernet network adapter. Remember, that's a network adapter that aids the devices to be connected to switches with Ethernet cables. And an Ethernet hub or switch. A switch is a network device that is able to route traffic on the same local area network. Ethernet cabling is the connecting medium at which the devices will be connected. For example, a laptop can be connected to a switch with an Ethernet cable. And lastly, a router, a network device with the ability to route traffic from one subnet to another. For example, connecting a LAN or local area network to a WAN, wide area network. If a business has a wireless network, it would need a wireless network adapter to aid connection to access point wirelessly, and a wireless router to route traffic from the access point to the ISP, or Internet Service Provider, and a wireless access point. That is a device to amplify the connection to different areas on the building, and a wireless modem to route traffic directly to the ISP with the use of a SIM card. Lastly, if the small business has a hybrid network, it would probably use more than one type of connecting technology or topology. Remember that word from Lesson 1? So it may need the following: a network adapter, a switch, Ethernet cables, a router, wireless access point, and a firewall. You may have already met young Morpheus, our resident AI chatbot. He's here to help you with any questions or issues you have during this or any other lesson. If you're attending the live lesson as opposed to a recording, you'll also be able to chat to your fellow classmates using this platform. And if you've ever received any strange responses from him, please immediately send an email to support@shawacademy.com. You see, because Morpheus is still in his infancy, he can do some rather unexpected things at times. As already mentioned, a small business needs to be able to share data and resources with all its employees by giving them the ability to access networks, printers, files, and the internet so that they can connect with their current and potential clients. The type of network, wired, wireless, or hybrid, would be based on the specific needs to a business. Now that we know what equipment you would need to set up each type of network, let's look at the structure of each one more closely. A wired network is traditionally the use of network Ethernet cables that vary in speed, ranging from crossover cables, Cat5, Cat5e, and so on. Now, these cables can transmit data from 10 to 1,000 megabytes per second, depending on the cable type. They also connect devices in the network, such as computers, network, printers, together to the ISP. Let's look at the main advantages of a wired network. First up, security. Now, a wired network has a lot of benefits, and security is one of them. Every user will need to be physically connected with an Ethernet cable to access the network, which increases the level of security. Speed is another example. Speed relatively depends on the type of Ethernet cables that are used in the network. For example, a Cat5, a Cat5e, Cat6, Cat6a, or a Cat7, to name only a few. And finally, there is no wireless interference. In a high-tech environment, there are a lot of radio signals being transmitted in the air from network devices like extenders and repeaters. A wired environment is not affected by these radio wave interferences. The disadvantage of a wired network would be that it is costly. It often costs a lot to run network cables to every part of a building where a network connection is needed, and this may lead to some areas without internet connection. Also, devices need to have an Ethernet adapter to be able to connect to this network. The devices in a wireless network are all connected to the internet without the use of network cables as in a wired network. Wireless network uses access points to amplify network signals to all the areas where the network connection is needed. The advantages for this network type would be that it brings convenience to the user and that they can simply connect to the wireless access point close to their location. They are very inexpensive to set up. And lastly, it is easily scalable. For example, the wireless signals can be easily amplified to near areas with an extender when needed. The disadvantages of a wireless network would be that it often requires a higher design specification to transmit data at a high speed, and it is prone to interference. It is often affected by lead materials, metals, magnets, walls, and so on. A hybrid network is mostly used by businesses with a larger number of employees, where there is a combination of wireless and wired networks to form a hybrid system or network. Routers are connected to switches with Ethernet cables, and the switches are connected to access points to reach areas where direct cabling cannot reach in the building. All routers have a default gateway to the ISP. A hybrid network is the most desired type of network. Let's have a look why. Firstly, it is a combination of wired and wireless networks to produce a high-speed network with a good flow of data through the wired and wireless network. And also, its affordability is another big plus for the hybrid network. Businesses tend to save a lot of money on cabling when wireless access points are generally used throughout the business, and cabling is only used where required. However, there are disadvantages of a hybrid network. It often requires a lot of planning and time to set up. Network engineers would need to map out the entire building and locate the areas where it requires access points or cabling. Also, a hybrid network has a lot of network devices that require maintenance and management, so hardware that tends to break and may require replacement. Did you know the ISP you choose can greatly affect your internet connection speed? Many internet service providers advertise their upload and download speeds. However, these numbers aren't always accurate. It's always a good idea to do your research and find out what their real internet speeds are. After this lesson, you have your first weekly assignment, which is based on the topics we've covered in this lesson and the previous one. These are not compulsory, but if you choose to complete the full course, which I hope you will, they are great preparation for your final assignments. We're going to jump into a practical demonstration now to show you how to set up a small network. In this demo, I'm going to show you how to install Cisco Packet Tracer on your laptop. So, to get started, all you need is a laptop and the internet. Go to a web browser and type in netacad.com. Now, this will take you to the web page. Cisco is a networking academy that trains people who are interested in learning more about networking. Okay, so the next step is to go to the Course tab section and scroll down to Packet Tracer. Click on Packet Tracer. And that takes us to a new page that explains more about it. So what is it? As explained previously, it is an application that simulates a network environment with network devices. This is basically an overview from Cisco showing what it is all about. We can clearly see who would make use of Packet Tracer. People who are interested in networking, people who are probably going for some form of networking certification, such as the CCNA or CCNP, and educators who use Packet Tracer to train students. It's really a very simplistic way of actually showing students how networking devices are configured and how they function and communicate with each other. As you can see, this software is totally free. There is no fee to install and download this piece of software. So to get right into it, what we have to do is to click on the Introduction to the Packet Tracer course. And that takes us to the page where we need to sign up. Basically, the sign-up process is just to show Cisco that you're actually interested in learning more about the software that they've created for their students. I will be signing up in English. In my case, I already have an account with Cisco, so I would skip this step of enrolling for the course. In your own case, you would simply put in your first name, your last name, your email address, and tick all the fields required. Do you need updates from Cisco on new learning materials? If you do not need or want this, you click on this box. Once you're done, you would click on the verification button, and that says you have to be over the age of 13 to use the software. And then you have this simple arithmetic to check that you're actually a human being. Okay. And that's it. When you're done with this process, you should be on the same page as me right now. At this point, I'm going to pause the video and we'll be back when I sign in. Okay, welcome back. So as you can see, I'm signing in. This is my last name and I'm inserting it here. The next step is to install the Cisco Packet Tracer onto your machine or laptop. Scroll down to the Introduction package for students. This is not mandatory. It's just a kind of convenient way for Cisco to help students more to familiarize themselves with a networking environment. If you really want to know more about Packet Tracer, you could enroll for the various courses. Just a reminder, this course is absolutely free to help you to give you more insights into networking. Now, I already have the Packet Tracer installed on my own local machine, but I'm going to take you through the process of installing it. If you're not interested in reading the various materials and want to go straight into installing the program, you would scroll down to the Resources section on the page. In the Resources section, you have the self-paced course from Cisco that I referred to earlier, and the Packet Tracer tab. Click on the Packet Tracer tab, and that should take you to another page where you will see Download Cisco Packet Tracer. You can actually review this webpage to verify that it is actually coming from Cisco. Now we can see the URL and also see that the page is secure and from Cisco. The next step is to choose what kind of device you're working on. In my own case, I have a Windows laptop. You might have a Linux or a MacBook. Cisco has actually modified the piece of software so that it can also run on Android phones as well as iPhones. I'm going to download 64 bits because that's the specification of my own laptop. I'm going to click on 64-bit download, and it should take me to the prompts for downloading. We can clearly see the software downloading. I'm going to pause again until the download is finished. Okay, then we will jump right back in once Packet Tracer has been installed. Okay, so all I needed to do was to click on the prompt to actually go ahead with the installment. At this point, the installment process is being initialized. So what do we have to do? Nothing. This is just an agreement statement from Cisco telling you if you're gonna use this piece of software, you would have to agree to their terms and conditions. So I'm gonna tick that I agree and then click on the next button. The next step is to choose a location for where the Cisco software will be stored. In my case, it'll be stored on my C drive on my laptop under Program Files. I just click Next, and that takes me to the next page. So we click Next again, and it asks me if I want to create a desktop shortcut. So if you want it to appear on your desktop, you would click on it. Alternatively, you can create a quick launch shortcut like this. It depends on your preference. Okay, so my Packet Tracer is fully installed and it's good to go. So basically, I'm just going to give you a quick overview on how the package works. As you can see, on the left-hand side, I have a bunch of icons. When I move my mouse over the icons, you can actually see that they represent my networking devices. And if I move my mouse here, it shows me my endpoint devices such as my laptops, PC servers, network printers, my TV, and my wireless tablets. Here are the components. Now, this refers to the networking components like motherboards. The next icon shows the connectors. Now, under connectors, we have different sets of connectors that we use. So, cabling. We have the console cable that's used for management purposes. And we have the copper straight through. And we also have the copper crossover cable as well. Now, all these cables have different capabilities. In the packet tracer, you're able to see that. You can configure your network devices. You can see how they operate and how data is being transmitted. So how the data travels on every connector at different speeds. So depending on the kind of speed you want, you would choose the kind of connector at the bottom here. You can actually see my network devices such as my routers. I can click the router and drop it into the screen. You can see my switches, my hubs, my wireless access points. You can see my security. And you can see my internet. Basically, these are the essential tools of networking that we all use on a day-to-day basis. And these are just the adaptive security appliances that we can configure. Now, we need to configure on our access points or on our switches on Packet Tracer. These switches and routers behave like real-life switches because basically it's a simulation of the network device. So if I click on this switch, I can clearly see the model of the switch and I can see the ports the switch has. I can see the logical on button for the switch. So I could also choose to turn the switch off if I want to. So as you can see, it's a very practical way of learning about networking and how to configure networking devices. This is why Packet Tracer is so useful. It enables you to learn how to actually configure networking devices in your own spare time. It also shows you how to set commands. You can see the interfaces we have on each port, and you can manually configure the ports. Play around until you become familiar with it. And that brings me to the end of this demonstration introducing Packet Tracer. For the last part of this lesson, we're going to go through an overview of a network architecture using Packet Tracer. Packet Tracer is a cross-platform visual simulation tool that enables users to create network topologies and imitate modern computer networks. Okay, welcome to the lab demo. Now, in this lab demo, I will be showing you how to set up a small network for your business, where I will be simulating a connection from our coffee shop to our ISP. I will be setting up laptops to switches and our router to our ISP. I will be working with Cisco Packet Tracer. In Cisco Packet Tracer, you can configure network devices in a simulated network environment, which has different network devices. You can configure your network devices and see how the devices interact, like in a real network. And we'll be configuring our simulated coffee shop to the internet. And I will see how it behaves. And if necessary, I could also implement changes to our simulated version before we actually make it physical. Okay, so let's start with the connectors. First, we need to connect our connectors, which are the cables in our network. And we will start off with the routers and then work our way down to the laptops. Now, at the bottom of the screen, we have this icon. When I click on it, you can see a bunch of different connectors. And for our router, we would need to select a serial connector. When I click on the router, I can clearly see the kind of router we have. And I can see that there are no serial modules installed on this router. So, because this is Packet Tracer and it's a simulation, I can simply turn off the router, and then I will install a serial module by clicking on it and dragging, and then turning back on the router. Now we're gonna do the same for the other router. So I click on the router, and I can see it has a serial number installed already. So I will leave it as it is. So now we go down to the base, and we can simply click on the icon again and select a serial connector. So we click on it, and we go to our router and click on it. And it shows us all the interfaces we have on the router. At this moment, we're connecting onto the serial interface. So we click on serial 0/1/0 and connect that to our router at the coffee shop. So we click on it as well, and we see the same interfaces, and we connect on to serial 0/1/0. Okay, then I have to coordinate our routers and switches together. In this case, I'm going to be using a connector, which is a copper crossover connector. So I click on there, and I go back to my router. I click on my router, and in this case, I'm going to be using the Gigabyte Ethernet 0/0. We mostly use the Gigabyte Ethernet between our routers and our switches, which helps to speed up our internet connection, and it also scales up our productivity. So rather than having a default slow connection, you would have a faster internet connection because of your connectors. So I click on Gigabyte Ethernet 0/0 and do the same on our switch. So I choose Gigabyte Ethernet 0/1. Now that we have this process done, we repeat the same steps on our switches. So we click back on the icon, and we choose the copper crossover, and repeat the same step on our switches. Okay, now that that is done, all we have to do is connect our switches to our laptops. And to do this, we go back to our connectors. We click on our connectors, and this time we're going to be using the copper straight through. So we click on the connectors, and we go back to the laptops. And we choose from the interfaces we have on the laptop, and we choose the fast Ethernet. Click on that, and we simply connect to our switch. In this case, we're going to be connecting on to a fast Ethernet port on our switch. So we will repeat the same process for all our laptops. At the moment, I have already connected all the cables to my laptops. So when I mouse over my switch, I can clearly see I have 24 fast Ethernet ports. I have 2 gigabytes internet ports, and I have 1 VLAN. Now, this is fine for creating a small network. For our coffee shop, if I wanted to create a larger network with more computers connected to our switches, we're going to assign the IP automatically. And I could assign the IP automatically by using a DHCP server. In Lesson 3, I'll be talking more about DHCP servers and how they work in a network environment. In this case, I have just a few laptops in this lab demo. So I will be assigning the IP address manually. So to do this, I go to the laptop. I click on the laptop. I go to the desktop, and I go to IP configuration. In my IP configuration, I input the IP I want to assign on the laptop. In this case, I'm assigning the IP 192.168.1.2 and a subnet mask of 255.255.255.0. And a default gateway of 192.168.1.1. So we repeat the same steps on all our laptops and insert these IP addresses and also the default gateway. Okay, so now we have all of the ports connected. There is, however, still an issue with our network. The issue is routing traffic out to our ISP. Remember from our lesson 1, I said the switches can route information on the same local area network? Now, this means that at the moment, PC or laptop 0 would be able to ping laptop 5. Or will be able to communicate with laptop 5 because they're on the same local area network. Now, let me show you exactly what I mean. So if I was to go to laptop 0, so I click on lot 0, I could go to CMD, which is called command prompts. I click on command prompts. I could simply type in a command, ping 192.168.1.7. And we can clearly see there is a reply from the ping. So from the ping statistics, we can see 4 packets were sent, 4 was received, and 0 was lost, which is very good. This means there is very good connectivity between laptop 0 and laptop 5. So that leaves the question, how do we send traffic from our local area network out to the internet? So to do this, we will need to make some configurations on the ports we have on our routers. So first, we would have to install an IP address on our default gateway. And to do this, we simply click on the router, and we go to CLI, Command Line Interface, and we see a command line interface where we can actually issue commands and make configurations to our router. So first, I simply type command, enable, enter, configure terminal, and next we want to install an IP address on our default gateway. To do this, first of all, we need to type in the command interface. Now, in this case, we are working with interface Gigabit Ethernet 0/0. So we're going to type in the command interface Gigabit Ethernet 0/0 and enter. So at this point, what we can do is put in the IP address for the interface, and we simply type a command IP. So it's IP address 192.168.1.1. And the subnet mask of 255.255.255.0. What do we do next? We type in the command no shutdown. Enter. Okay, now the reason we type in the no shutdown command is to physically bring the interface up. So at this point, we want this connectivity from our switch to our router open. And we want traffic to be able to travel through this connector. Now, to see if this IP is installed on our default gateway, to see if it's actually functional, we can actually use the ping utility on our laptop to test that out. So what we can do, we can go back to command prompt, and we can actually test to see if the default gateway has connectivity to our laptop. So by typing in the commander ping 192.168.1.1 and enter, and we can clearly see at the moment we have replies. And from our ping statistics, we have 4 packets sent, 4 received, and 0 lost, which means at this point we have very good connectivity from our laptop to the point of exits from our network and out to the internet. So at this point, let's continue our configuration. So what we're going to do next, we can issue IP addresses. All right, guys, let's continue with our configuration. So at this point, we need to install IP addresses on the serial interfaces we have on our router. So we're going to continue from our coffee shop router, and we're going to go back to the CLI, command line interface. And what do? It's simple. We just implement the same process we've done before on the CLI. We simply type the command. So we type in the command enable, enter, configure, terminal, and enter. And now we're trying to configure the serial interface. So what do? We type in the command interface, serial 0/1/0, and enter. And what do we do next? We're moving on to the IP address. And the IP for that interface is 212.1.0.100. And the subnet mask 255.255.255.0. Enter. And we type the word no, shutdown, to bring the interface up. So at this point, we have brought this interface up, but communication goes in 2 ways. We also need to actually bring this other interface up. But in a real-life scenario, this will be handled by the ISP. But because we are actually playing roles in the setup, we will also be configuring the router for the ISP as well. So to do this, we simply go to the ISP router, we click on it, and we go to CLI. and we type in the command. No, enter. And what do we do next? Now we can actually type in the other commands. Enable, enter, configure, terminal, and enter. And now we're actually working on this interface on the ISP because we need this interface to be open. So we go to interface serial 0/1/0, enter, IP address 212.1.0.111. And it has a subnet mask of 255.255.255.0. And enter. And we type in a command, no shutdown. So now you can actually see the lights just went from red to green, which means at this moment, both sides of the interfaces are up. So traffic will be able to actually travel through our connectors. At this point, we cannot still talk to our ISP because we have no form of routing protocol on our routers. So what do we need to do? We need to go back to our routers and manually configure routing protocol. So to configure our routing protocol, we can either choose to use a static route, or we can actually choose to use a dynamic route such as RIP or OSFP for routing. But in this case, we're not going to use the dynamic routes. We're just going to make it very simple and use a static route in our network. And to do this, we need to go back to our router and configure a static route to the internet. And we do the same to the ISP. Okay, back to our network. So let's get started. So on the CLI, you type in the command again. Enable, enter, configure, terminal, enter. Okay. And now we type in the command IP, route. And in this case, we're going to be using a gateway of last resort. Now, what that means is that when we send a ping to any network, what happens is the router checks to see if that IP is actually issued on our network. And because we're going to be using a gateway of last resort, whatever IP is unknown to our network, it would just send their packets out to the internet and let the internet search to see whatever result it gets. And it actually sends that reply back to the sender to issue a gateway of last resort. So we type in the IP 0.0.0.0 space and the subnet mask of 0.0.0.0. And was this the next hop IP? So now in this case, we are at the coffee shop, and now we want to send every traffic to this network. So basically, we have the gateway of last resort. So every unknown traffic is sent out to the internet. And the next hop IP is the internet. So we put in the IP, which is 212.1.0.111. Enter. And that's it. And at this moment, we're done configuring the routing for our coffee shop. Now we need to go to our ISP. Because this is Packet Tracer, in real-life scenarios, you do not need to configure your ISP router. Your ISP would manage your own router and make any configurations and changes that they need to. So in this case, we're just going to repeat the same steps we actually had on our coffee shop router on the ISP router. So what do? We type in a command again. Enable, enter, configure, terminal, enter, IP route. Now, in this case, we're not going to be using the gateway of last resort. Why? Because we know the network we should go to. So in this case, we're going to be coming back from our ISP back to our network. So we're on this router, and we want to be able to send traffic back again as a form of replay to our network. Okay, so we type in 192.168.1.0. Now, this is called an IP summarization. So this means that every IP address that falls into the 192.168.1.0 network will send the traffic out to the port, back to our network. So what do? We type 192.168.1.0 with a subnet mask of 255.255.255.0 space. And next, hop IP to our network is 212.1.0.100. And enter. So basically, that is all of our configuration done. We can now simply test to see if we have connectivity to the internet. So to do this, we can simply pick any of the laptops. I'm going to pick the laptop 2. And we go to command prompt. And we type the command ping our internet. But we're going to type the IP address of our internet, which is 212.1.0.111. And enter. Okay, at this moment, we can actually see we have a replay from our ISP, which means we have the connectivity from our local area network out to the wide area network, which is our internet. We can also see from the ping statistics that we sent 4 packets and 4 was received, 0 was lost, which means we have very good connectivity. All right, that ends this section of the video. This lesson was just to show you how to actually set up a small network for business. You can actually implement this on your own time. Did you know that IP address 127.0.0.1 is reserved for loopback or local host connections? This means that when you point your browser to this address, it tries to connect to the computer you're using, which is handy when you want to connect to a server on your own computer. If you haven't already, I would recommend that you download our app to attend the lessons on the go and manage your class schedule. You can attend your lessons and watch recordings on any device, laptop, desktop, tablet, mobile, you name it. Remember, all the summary notes and slides are available in your toolkit and would really be worthwhile to keep as a resource at your fingertips beyond this course. As we draw to a close to our Lesson 2 of cybersecurity, we have concluded that small businesses need a network to be able to share resources with one another and communicate with their potential and current customers. We looked at the factors to consider and benefits of computer networking. We discussed how businesses have the option of implementing a wired, wireless, or a hybrid network, and this usually varies on the needs of the business. We evaluated each of those 3 network types and their respective advantages and disadvantages. And lastly, we looked at how to set up a small network. Congratulations! You have completed your second lesson. I really hope you enjoyed it, and I will see you soon for Lesson 3.